the definition gives rise to different components. So I said things to know under vectors. Things to know under vectors, number one, definition. Number two, I said how to find magnitude as well as direction. Number three, I said dot products as well as cross products. And the last one is actually the perpendicular and parallel vectors. So these are the 4 items that I said you need to focus on in Game 1. Right. Also, vectors come in different categories. You have vectors in your you also have vectors in your plane. So this is just vectors step 1. And vectors step 1, we only focus on the definition, how to find magnitude and direction. Now, the way you can find magnitude and direction, you can use different methods. You can use triangle method, or you can use analytical method, or you can use parallelogram method, or you can use polygon method. You understand? Graphical. Now from there, we did analytical method, we also did parallelogram method. Now, next we are going to focus on dot product and cross product. That means we remain in the perpendicular and parallel. Of course, we are done with the tomorrow. We are starting kinematics. Yeah, we are done with vectors. We are starting kinematics, which is the last one in the morning. Right? Dynamics will end in because in the morning and yeah, so that means we'll be meeting with just for revisions now. And today we did part of revisions from dimensional analysis and vectors. That means this group one. Tomorrow is Saturday. Tomorrow is Saturday. So tomorrow we are going to meet. Yeah, we're going to meet tomorrow. We can go to vectors, right? Yeah, tomorrow I'm going to meet with concrete vectors. While we are making the evening so that we start kinematics calculus. Yeah, of course kinematics is calculus here. So we deal with calculus only. Yeah. So you guys tomorrow we are meeting. I'll make a makeup class. If you want, you just come, if you want to come. Yeah, but you learn the new things. So now today let's focus on dot product. Now, before we focus on dot product, let's focus on vectors in 3 dimensions. Vectors, we are here. Right? We are on the 3rd point here, dot and cross product. Now, vectors in 3D. Vectors in 3D. Vectors in 3D. What is it? Vectors in 3D. What is it? Vectors in 3D. Do you remember vectors in 2 dimensions? X and Y. So when you talk about vectors in 2 dimensions, 2-dimensional vectors, actually we're talking about X components and the Y components. Do you remember this? So every time you hear the word 2 dimension, you hear 2 dimension, always think of X and Y. Every time you hear of 2 dimension, think of X and Y. Now, what is the unit for X? I. Unit for Y is what? J. So vectors in 2 dimensions. Vectors in 2 dimensions have I and J. I refers to X components, J refers to the Y components. So vectors in 2 dimensions. In real world demonstration, how can I demonstrate vectors in 2 dimensions? For example, have you seen the way I'm working my let me demonstrate vectors in 2 dimensions. Because I don't have enough. Have you seen? Have you seen the way I've done it? Now, this has no effects because what is the dot product is 1? Because this is 0, because 0 is 1. Now, I'm here. Like, are you see what I'm doing? This is vectors in 2 dimensions. Because I'm only pointing in one direction, and this vector arrow, this arrow is going up, down, up, down. Understand that? It's in the x-axis as well. If it goes up, it is like in the y-axis. That means this vector in two dimensions x goes up, y. X, y. So this is vector in two dimensions like this. Now, if I change the direction now, this is now vector in three dimensions. Understand? Because now I'm changing direction, I'm moving up, down, again I move like that. This means this is a real demonstration of vectors in two dimensions and vectors in three dimensions. If you are pointing an arrow in one direction and that arrow is going up, down, it's vectors in two dimensions. Up, y-axis. That's x-axis. Now, if I change the position, it means I have added another component or another axis, which is the z-axis. So vectors in three dimensions, we just include another axis, which is the z-axis. Easy. So vectors in two dimensions, it is x, y components. What about vectors in three dimensions? Now we include the z-axis. Now, what is the unit for this z-axis? K. All right. So vectors in three dimensions has three units: I, j, and k. I refers to x, j refers to y, and k refers to z-axis. So I refers to x component, j refers to y component, z refers to k refers to z component, k refers to z axis or z component. So where you see I, you see x. Where you see j, you see y, and where you see k, you see z. Now let me draw a certain diagram in three dimensions. A diagram in three dimensions. By the way, we have not started the term exam. I just want you to be familiar with that. And what I'm doing, you know that it's called introduction. You have not started physics. Eh? Yeah, TM1 you just do introduction. That means real physics I am. Yeah, TM1 is just my introduction. You finish the whole thing just introducing physics. Yeah, so we have 3 months to introduce physics. Yeah, that is TM1. From December to February, that's 26 February. So what you are doing are called introductions. You have not started physics. Yeah. So just be ready to suffer, especially if you are here. So now look at this diagram here. We have this horizontal line. We also have this vertical one here. Now, let's say this is y-axis, this is x-axis. I'm not going to draw a straight line there because it will also be called y-axis. Right? Now I'm going to indicate. Now imagine the vector is here. It is going up, down, like the way I was doing it. Right? That means this vector, if I just leave it like that, it means this vector is in 2 dimensions. That's right. Now, if I include another vector here, this now becomes the z-axis. Simple. That becomes the z-axis. Not like that, no. No, this is a Cartesian plane. So that is a diagram in 3 dimensions. And in our test, last year's test 1, the first question was show the direction of the unit vectors. If you can check, I sent the question. So how do you show now the direction? You know that x is I, y is j, and k is k. Z is k. Now, what is the movement of this plane? What is the movement of this plane? We always move from I to k, not from k to I. Understand? Always move from I, j, k, not k, j, I. If you move from k, j, I, now you are going to have negatives. And that's very dangerous. So that means the direction, how do you show direction? We move from I to j to k, like that. So, and the question can have 3 marks. Simple like that. If you check, I think I share the question. You just check. It's there. I'm on YouTube online. Right? So those who can't understand it, if you want to watch the video on YouTube, I'll share it. It's live. Right? Yeah. So vectors in 3 dimensions, and I'm doing it for someone. For someone like Evaristo. Like in the morning, I have 500 users. And just in the morning. For now, I don't know. So vectors in 3 dimensions. This is how you represent on a plane. So this is called a plane. Where this vector is lying is called a plane. That is a plane. Now, I want you to look into the body. Who remember those who are doing mathematical sciences? Who remember that out of the H into the H? Remember? Oh, we are all from so much talking. Yeah, don't worry. We learn the same things, don't worry. I want you to talk about it. It just confuses you. Now, so vectors in 3 dimensions has 3 components. It has x components, y components, and the z components. Now, the unit for x component is called I, the unit for y component is called j, and the unit for z component is called what? K. Now, what is a diagram of the unit vectors? How can you present these unit vectors on the plane? This is how you create. So how do you now move? How do you show direction? You move from I to j to k, not vice versa, please. The order is important. That's why when you're crossing vectors, you don't say I cross j. You don't say j cross I to give you 0. No. Or to give you 0. You say I cross j to give you 0. I know you don't understand, don't worry. I'll explain it. So what does I mean? What does I mean? What does I mean? I means what? J means what? K means what? Now this is a representation diagram of the unit vectors in 3 dimensions. 3 dimensions, I mean 3 components, x, y, and z. And that means 3 unit vectors, I, j, and k. Now, imagine, actually, it is not always going to be y. Sometimes it can be, you can draw something like that. Then this one can be z, it's up to you. This one can be y, and this one can be x. It's up to you how you draw it. It's okay. It's up to you. As long as it is a vector in 3 dimensions, you can draw. This one can be x, this one z, this one y. It's up to you. Because it's like at this point here, it's like at this point here, it is rotating like this one comes, it's rotating like that. In 3 dimensions, right? It's not only going up or down, it's rotating because there, you see now the cube is right? The cube, let me draw a cube here. If I'm going to draw it, let's say this is a vector, it's going to be what is that? No. Have you seen that? That is a cube. That cube can rotate. These points can be here. Again, these points can be there. These points can be here. Again, these points can be there. You see how the cube rotates, like the ice cube. Yeah. That is a vector in 3 dimensions. That is the representation of vector in 3 dimensions. It can rotate in 3 ways. It can rotate in the direction of x, in the direction of y, and in the direction of z. Yeah. So that means, now, imagine we draw another line there. Imagine we draw another line. This is the magnitude. This is the vector we have. And that means we are also going to complete this one here, so that we have a complete rectangle. Now, I want you to imagine something here. I want you to imagine something. Imagine this is a door. Have you seen that? Imagine this is a door. I want you to focus only on the shaded part. Focus only on the shaded part. The shaded part looks like the door is open. Right? If you move from here to there, it looks like it's open. Imagine I'm opening this door. Is that nothing? You understand? This one looks like a door. That means here you are going to have the angle according to theta 1, and between this one and this one, we're also going to have angle which we call theta 2. So using this information, this is now a right angle triangle. If you're not able to see that. Are you able to see that? Remember, these are introductions. Right? Those want to do engineering, those will be your introductions. Like, lesson 1, you can do. Yeah, of course. I can share the module that I'm using. So chapter 1, lesson 1, and the vectors in 3 dimensions in each of the one, which is statics and dynamics. And engineering. Every time you have also introduction, you will never learn about vectors, just that from me. And these are introductions, they don't even count because you know them. So if you don't know this in first year, it will be a challenge. Especially the most failed course, which is statics and dynamics. No, I don't want you to drive any questions here or any formulas here. I just want you to imagine the door. How the door is moving. Imagine this is the hinge. How do you imagine? This is the hinge. And this is the bottom of the door. The bottom of this door. And this is the top. I can call it H, and also this one I can call it H because this side is equal to that side. Now I can delete everything here and I can break this one into a right angle triangle, also this one into a right angle triangle. Then I can derive formulas from there. Get? Okay, what you need to know is vectors in 3 dimensions has what we call I, J, and K. Let me number this one. Vectors in 3 dimensions has 3 components, I, J, and K. Where you see I, where you see X component, you see I. Where you see Y component, you see J. Where you see Z axis, you see K units. Now, let me draw again, because there's one important thing that you need to understand from here. Let's say this is Y, this is X, and that is Z axis. Let's have a vector that is drawn between Y and X. Now, the angle between X and this magnitude F, the angle between X and F is what we call alpha, right? The angle between X and F is called what? Alpha, the symbol F. The angle between F and Y is called what? Beta. The angle between F and Z is called what? Gamma. That is what you need to measure. That is what comes in the gamma. Do you want me to draw it box fire? So what you I draw. I even said the do. Engineers. Engineer lecturer physics. I can't go what do medicine. Yeah, medicine. Medicine what? So go and do that. When the work will get it's that's fine. Yeah, those guys, those guys can so vectors in 3 dimensions as what we call I, J, and K. How do you move? You move from I to J to K. I'll send the question where they asked you to draw and show the direction of the unit vectors. And it was question 1, which corrects 3 marks. Yeah? Just drawing correctly here, you get 1 mark. Putting the correct X, Y, Z, you get 1 mark. Putting the correct directions, you get 1 mark. Total 3 marks. So you should know how to draw these lines, not straight like that. No, not straight. So if they say draw a vector in 3 dimensions and show the direction of the units, the directions. This is what they are talking about. Right? Your job is just to show that, oh, I moved like that, also like that, also like that, also like that. Why are you showing that? Because you know that X is here, you move from I to J to K. But what if Z was there? Let's say we are JX, here Z, here Y. Direction that question. Imagine here we had maybe, for example, this is X. Elo yachiva Y, so elo yachiva Z. What is the unit direction? Maybe you don't understand. What is the unit direction? What is the unit direction? Always remember that we move from X to Y to Z. That means we move from X to Y to Z and go back to X. That is the direction. Simple, guys. Always, vectors in 3 dimensions always move from I to J to K. The order is important here. Always move from X to Y to Z. Go back to X. But don't go back. Any question? What if we had X here? Hello, here, Y, Z. That question? So if you had X here, then here we have Z. Direction that was Y. Have you seen? Yeah, that was Y. Then you go back to X. Simple. So if the diagram was like that, if we had X here we had Z, and here we had Y. What is the direction of the unit vector? That's how they ask. What is direction of unity vector? What is the direction of unit vector? Unit vector, they are saying, what is the unit of X? What about Y? And they will specify to say, show in your diagram not X but I's. In your diagram, you should never put an X. You should always put an I. So if it's wrong, I'm supposed to say this is I, and this is J, and this is K. That means I, X, J, that is Y, and K, that is Z. Now, show the direction of the unit vector. How are you going to show? We move from here to where? So move from I to J. I wanted to sing another one. So move from I going to J. From J we go to K. From K we go back to I. That means 3 marks. Simple 3 marks. Just doing that you get 3 marks. Just doing that you get 3 marks. Now, what do we call the angle between x-axis and the resultant, the vector? Alpha. That means the angle between, this is x, and this is y, and this is z. So the angle between x and the resultant, the vector, is what we call alpha. The angle between y-axis and the vector is what we call beta. Now, the angle between this line, with this vector, and the z-axis is what we call gamma. Now, how do you find alpha? That's number 1. This question carries again 7 marks. So, and copper is not always depends with the where. So you can draw a little diagram and show the direction. So the diagram is not static. Yeah, no. It depends with how you take it, how you draw it. So if x is on top there, but upper y over x, it means it's you who knows how you're going to do it. Because you move from x to y to z. So it's up to you, and how the angle is going to be placed is up to how you're going to diagram. You just need to remember that the angle between x and y is what you call alpha. Remember, imagine if here we had x here. So Because I'm saying the angle between x and vector is what? Alpha. So don't just think in one, think outside the box. What is that? So just remember to say the angle between x-axis and vector is what we call alpha. Now let's focus on this. Let's focus on this diagram. Here we have I, here we have y, here we have x, and here we have z. Here we have the vector f. The angle between x and f is what we call alpha. The angle between y and f is what we call beta. The angle between vector and z is what? Gamma. Sorry, I've been sick. Sorry, I'm going to now, how do you find alpha? That is the question. Note that to find alpha, beta, and gamma, always use cos. Always use cos. So to find alpha, beta, and gamma, always use cos. So to find alpha, beta, and gamma, always use cos. Now master the following. Master time up. Now master the following. Master. So let's say you are here. This is rectangle triangle. What is cos? Adjacent over hypotenuse. This is the adjacent of what? Hypotenuse. Yeah. So master the following. Cos alpha equals to what? Always cos alpha equals to the x component of that vector divided by the magnitude of that vector. So this is the x component over the magnitude. That means the x component over magnitude. Now in this case, magnitude we are going to use R, because remember what I said in the introductory parts. A vector is a quantity that is called magnitude and direction. Magnitude is also means what? Resultant. And the symbol for resultant is R. So now cos alpha is given by x component of that vector over magnitude. For example, let's say we have vector A equals to 2i. Remember, what is I for? I is what? What is the axis? X-axis. That means 2x. That means this is the x component of this vector A. Now I ask you the question. What is the angle of vector A that it is making with the coordinate axis? What is the angle that this vector is making with this coordinate axis? This coordinate is about 6 months. What is the angle? That means you need to find 3 angles: angle for alpha, angle for beta, and angle for gamma. Now, because we only have the x components, anything that you see, the coefficient of I is called x components. The coefficient of I is called x components because I refers to what? So the number before the I is called the x component. That means to find the angle of cos alpha, to find the angle, it means we need to know to find alpha. Why are we interested in alpha? Because we know that it is only alpha that is related to I, and I is x. Like I said, the angle between x and this vector is what we call alpha. So that means to find alpha, we get the x component of that vector divided by the magnitude of this vector. So then we find cos inverse of that. Yeah. So that means cos alpha equals to what? 2 over what? What is the magnitude of 2i? What is the magnitude of 2i? 2. How to find magnitude, guys? Square root of x squared plus y squared plus z squared. And what is x squared here? What is x here? 2. What is y? What is z? 0. That means magnitude equals to 2 squared. That's it. Now we can cancel the square roots. Then 2 over 2, that means 1. So to find alpha, we say what is cos inverse of 1? That is the answer. So to find cos alpha, always get the component of x divided by the magnitude of that vector. To find cos alpha, get the component of x divided by the magnitude of that vector. Easy. Now what about cos beta? How do you find the angle beta? You say cos beta. You say, how do you find cos beta? How do you find beta? Beta is related to y components. Beta is related to y components. Like I said, beta is the angle between y and its magnitude. That means if you are looking for cos beta, get the component of y, because beta is related to y components. That means we are going to get the component of y divided by the same magnitude here. Easy. So cos alpha, how do you observe the pattern? What's happening? Don't just be looking out. Cos alpha equals to x over r, cos beta equals to y over r, right? Yeah. Y is actually the y component of that vector. Which vector? Vector f. Now, how do you find cos gamma? So you say cos gamma equals to, gamma is related to what axis? Gamma is related to what axis? Z. So that means z over magnitude. So z over magnitude. So that is what you need to remember to get 4, 6 marks. Now, how are they going to go through the equation? They will say, find the cosine direction of this vector. Cosine direction. Or they will just say, find the angles alpha, beta, and gamma. The moment you hear the words alpha, beta, gamma, please always remember those two formulas for cos. Cos alpha equals to x over r, cos beta equals to y over r, and cos gamma equals to z over r. Gamma is related to z, beta is related to y, alpha is related to x. That's it. Now, look at this. Let's say we have vector A. Do you know that, in case you forgot it, we are dealing with vectors in 3 dimensions. What does that mean? This vector can have x components, plus it can have y components, plus it can have what? That's what we're talking about. For example, now where you see x, what do you see? I. So I plus y, you see what? Plus k, z, you see what? So this is how you write a vector. That's it. That's it. Now, I'll give you the same vector here. Without even having numbers with show dash, I'll just give you the same vector. Now, I ask you the question. What is the magnitude of vector A? What is the magnitude of vector A? We calculate? You can say my own from side. So the answer is what? That means the magnitude of a unit vector, the answer is 1. What is this unit vector? I. What is the magnitude of I? 1. What is the magnitude of Z? 1. What is the magnitude of A? 1. That means the magnitude of any unit vector, the answer is always 1. So how do you find magnitude? You say magnitude of A equals to the square root of what? The component of I, the coefficient of I square. What is the coefficient of I? 1 square plus coefficient of Z, J is what? Plus coefficient of K, which is 1. So 1 square plus 1 square plus 1 square. Ah, you like it. You like it. Ah, guys, you like it. Ah, I like it. It's you like it. That's another point I couldn't what's up. Near abroad, what's in Harvard? Why should I know later Harvard? What is 1 square? 1. I was talking about unit vector, which is found by vector itself divided by the magnitude. So we say 1 plus 1 plus 1 is what? 3. So this is the answer. Units. So the magnitude of vector A in this case, we have found the square root of 3. Now ask you the question. Find the value of alpha, beta, and gamma. Find the value of beta, gamma, and alpha. That's your question. Find alpha, beta, and gamma. So find alpha, beta, and gamma of vector A. And they'll give you free 6 marks. If you check the papers, they'll give you free 6 marks. I don't know why. So find alpha, beta, and gamma of that vector A. How do you find cos alpha? How do you find alpha? What figure should you use? So I'm going to say cos alpha. Now, how do you find cos alpha? You get the x component of this vector, which is x component divided by the magnitude of this vector, in this case, square root. That means magnitude of vector A. Or if you want, you can put A, magnitude of A. Okay. Now, what is the x component? We are looking for cos alpha. What is the x component of this vector A? 1. Easy, guys, easy. That means cos alpha equals to 1 over, what is the magnitude of that? Can you fail to find cosine? Cosine is okay. What is the angle? Please give me. What is alpha? What is cosine base of 1 over square root? What is this measuring weight? Without measuring. Because for what? Adjacent over hypotenuse. Yeah, adjacent over hypotenuse. Let's no 45. 45 come out square root. Initially, let's open 866. If you divide square root of 3, 10 is 0.866. If you have, yeah. So what is the angle? 54 point what? 1 decimal place. So that is alpha. You get 2 marks, 2 marks from there. What other angle are you supposed to know when you're finding cosine direction? What other angle are you supposed to know? Guys, are we from grade 12? What other angle are you supposed to know? So how do you find cos beta? We had vector A equals to I plus J plus K. How do you find cos beta? How do you find beta from there? Yeah, so you say cos beta equals to y component of this vector divided by the magnitude of this vector. So that means cos beta equals to, what is the y component? 1 over what? What is the answer? 54. 54.7. Now we go to the gamma. How do you find gamma? You get the component of the component of z. So cos gamma equals to the component of z divided by the magnitude. Cos gamma equals to z over magnitude. Get the z component of this vector divided by its magnitude. So gamma equals what? Same way. So that means 54 point what? Now I want you to focus on the numbers. And let's go to the next step. Now, those who are doing algebra, do you remember the multiple angles, compound angles, identity Z? Yeah. Do you know that cos squared theta plus sin squared theta equals to 1? Do you know that? That is what you're going to prove here. Because it comes and it's carrying 3 marks. Yeah. I just hope you're not forgetting where we are coming from, because we are just connecting it. Yes. So now, let's look at a proof. Prove that cos square alpha plus cos square beta plus cos square gamma equals to 1. 3 months. 3. 3 months. Tapai never work with the difference. Tapai never work with the difference. Naman goes tapai. Vectors in 3 dimensions. We are here. The problem of so, how can you prove cos square alpha plus cos square beta plus cos square gamma equals to 1? How can you prove that? Your job is to know what does cos square mean. Cos square means what? Cos times cosine. That means cos to the power of not. So number one, we are going to say this is the same as cos alpha to the power. Do you know that? It means cos alpha times cos alpha. What is cos alpha times cos alpha? What is cos alpha times cos alpha? Or what is x times x? Well, I'm not finished. These guys. And when you get my class, that's not maths. That's why. Yeah. If you don't have math, physics will be a challenge for you. Plus, what does cos square beta mean? What is the other way of writing this? What is the other way of writing cos square beta? That means cos beta square plus again cos gamma square equals to 1. Now, how do you find cos alpha? That is the question. How do you find cos alpha? What is the formula for cos alpha? X over what? That means cos alpha is the same as, remember, cos alpha, I said x over r. Cos beta, I said y over what? And cos gamma is what? Z over r. Always remember that, please. Where you see cos alpha, you see x over r. Where you see cos beta, you see y over r. Where you see cos gamma, you see z over r. Now just get this and substitute the character that equals to 1. So what is cos alpha? Where there is cos alpha, put x over r. That means x over r. Now everything is squared. You get? Plus cos beta. Where you see cos beta, what do you see? So y over r. If you love math, this is simple issue. What is cos gamma? How do you find cos gamma? Z over r. That means z over r. Everything is square. Equals to what? You are proving that whatever you are going to do here, whatever mathematics you are going to do this side, is supposed to give you 1. That means manipulate these letters to give you 1. That's what we are doing. So how do you prove cos square theta or cos square alpha plus cos square beta plus cos square gamma equals to 1? How can you prove that? And this one, mostly it comes in an example. Now here, make sure that you distribute the power. This means x squared over r squared. That means x squared over r squared plus y squared over what? R squared plus z squared over what? R equals to what? 1. Now, look at the denominators. If the denominator is the same, what do you do to the numerators? It's simple. So when the denominators are the same, just add the numerators. What is x squared plus y squared plus z squared? What is the answer? The same one, right? Are you sure? Are you sure? So that means it's going to be x squared plus y squared plus z squared over what? R squared. Equals to what? We are proving that whatever we do this side gives us 1. Don't worry. Where is this coming from? We know that x over r is equal to alpha, y over r is equal to beta, z over r is equal to cosine. Gamma. Now the question is, how do you find what is r? Resultant. How do you find resultant? Resultant equals to what? X square plus what? Plus what? Now let's substitute. So that means x square plus y square plus z square over. Now remember, this r, everything is squared, like there is r squared. That means square root of x square plus y square plus z square. Now everything, the r is squared, do you understand? This is like r square, you get it? So that's, and this is supposed to be equal to 1. So that this one and this one can cancel out. Okay? Easy stuff. Any star. If you don't know any star of R, you are like me. J which J does. How can you know all the stars in English and also physics? So some stars are supposed to be known by faster. Now we can simplify. So x squared plus y squared plus z squared over what? Cannot consider. That means over x squared plus y squared plus z squared equals to what? Now, is this the same? Can you cancel that? Okay. For example, if you have 2x minus 4 over 2x minus 4, what is the answer? 1. So that means we can cancel that one and that one. So that means here we are remaining what? 1. What is 1 over 1? So is 1 equals to 1? So it's a yes proof. So physics is mathematics. Don't know mathematics? So the square root of that. So guys, where did this come from here? Where did this come from? Resultant side. Formula for resultant. Now, because R is squared, so everything is squared there. Now, do you remember the gamma we found and the beta and the alpha we found? The answers. Now, another question that they can ask you, it's this. I know questions they bring. You will see, you'll be surprised in test 1. So, they'll give you something like this. Given alpha equals to 54.7, right? Let's find the other numbers. Some people can say the reason why it's giving 1 is because we have same angles. No. Okay. Let's do this. Let's do this. Let's look at vector A. Vector A equals to 2i minus 3j plus 4k. Now the question is, find the angles. This question carries 6 marks. Find the angles that vector A is making with the coordinates, coordinates axis. And it carried 6 marks. Those who have test 1 papers, you find this question. You find it. So given vector A, find the angles that vector A is making with the coordinates axis. Axis, it means we have x-axis, we have y-axis, and z-axis. How do you know? Let me ask you. Is vector A in 2 dimensions or 3 dimensions? Because we have x, y, and z. Where you see I, this is x component. Where you see j, this is y component. Where you see k, this is z component. So what is the angle? You find the angles that vector A is making with the coordinate axis. How do you find that? Okay. Let us plot. I want you to know something here. Can you sketch this vector? You can. What is x component? Positive, right? Yes. Don't focus on the number, focus on the sign. So how can you sketch A? Now one need to start with the x component. In this case, it is positive. Whereas, let's say when you choose this is x, this is y, and we don't do like that. This is z. So that means we are going to have something like this. Y, it's negative. So that means on top, below, that's why we are going to have y. Understand that? Yeah, we're going to have y there. If this one is positive, let's maybe say this is the z-axis. Negative. This one is rotating. I don't know if you can imagine. There's a projector here. Whereby I know I need to connect. There's a projector whereby I can just take you YouTube and then I show you the vectors in 3 dimensions. Simulations, we call it simulations. So that you see how vectors in 3 dimensions move. Understand that? So when you go home, please make sure that I know you can't see what is happening here because this is a dot. It's like a cube. Now it's rotating like that. You get that? It's rotating like that. When you go home, search on YouTube vectors in 3 dimensions simulations. Simulations. They will show you everything that happens there. They will give you examples of cubes, shine, moving. Yeah, which is not even important, but you want to understand here. So don't worry, they want us to sketch. You can sketch anything you want. What is important is how you move. You move from x to y to z, then back to x. Now, find the angles that vector A is making with the coordinates axis. The question is, how do you find the angle? What do you use? What do you use to find the angle? Confidence, guys. Do you know why most people fail with confidence? Right? So they don't want to be Mexico doctors, chemical engineers. You want to be teachers. Right? You know, here we have only 2 programs. 3. We have engineers. Both one line. We have engineers. We also have doctors. It's one. And we have about 200 engineers and 200 doctors. Right? That means from 7,000, like 7,000 in one. So 7,000, they only get 400. Right? 200 to score medicine and 200. So right now we are 200. Most of them here. Where is the rest? What is it? Yeah, we take programs, they go into there, teachers, physics in education, physics, all those things. So you need to be very careful. Find the angles, guys. Let's find the angles. Find the angles that vector A is making with the coordinates axis. Find the angles that vector A is making with the coordinates axis. What are we going to use to find the angles? You're blind. What 3 relations do you use? So to find the angles that a single vector is making with the coordinate axis, we use cos. Now, what do you find? Angles what? Alpha, beta, what? Gamma. I don't know why you're interesting because you are just 29. You know the movement is 9. Just 29 years old. Then you're forgetting. You're forgetting about this. Yeah, I'm on them. So you're going to find what you call cos alpha, cos beta, and cos gamma. So number 1, you start with cos alpha. How do you find cos alpha? How do you find cos alpha? That means get the x component of this vector. Divide it by the magnitude of this vector. So what is the x component of that? 2. Now, what is the magnitude of vector A? You say this one square plus this one square plus that one square, everything under the square. What is the magnitude? So let's find the magnitude of vector A. So magnitude of vector A. You say the component of x squared plus the component of y square plus the component of z square. So 2 square plus, my bracket type, because this is negative. Negative square gives you positive. So minus b square plus 4 square. Please tell me the answer. 4 plus 9 plus 16 is what?
29.
29, eh? So square root of 29 units. So that is the magnitude of beta. Now, how do you find alpha cos alpha? You say component of x over the same magnitude of beta. So 2 over magnitude of square root of 29. How do you find alpha? What's the index of that? What is the angle? What angle is it given? What angle? What's the angle? 68.1? 68.2. What other angle are you supposed to find? How do you find cos beta? Cos beta equals to what? You get the component of y divided by the same magnitude, square root of 29. So what is the component of y?
Negative 3.
So we are going to say negative 3 divided by square root of 29. Ignore the negative. What is the answer? Try to put the negative. What's the negative on the calculator? So what is the cos beta? What is beta? Guys, we have done this. We are just revising.
123.
What is beta? Angle beta is what?
123.9.
So 123 point what? 9 degrees. What other angle are you supposed to find? Gamma. So we say cos gamma. Is the angle negative B? Yeah? Is it giving negative B? No, just put the negative. If you ignore the negative, it means we're supposed to go back to the issue of quadrant to the top. Where is what's negative? You say all students take of correct, then you subtract from this. I don't think it is. I'm saying include the negative to find the final answer. No, not under the little method. Not here. You need to find the actual answer. Under analytical method, we find reference angles, right? Yeah. Then you can go back to the sketch and find the final answer. Now here you just include the negative. Whatever answer it gives you, write that answer. So if you include the negative, what answer is it giving? Yeah. If you ignore negative, what answer is it giving? It's exact. Now ask yourself, where is first negative? Where is first negative? I mean, this means all sign positive. That means in the second quadrant, cosine is negative, right? That means subtract 180 minus 056 by whatever you get. You get it? Yeah. If you go back to the top, guys, no, you are grown-ups. So let's find cos gamma. So cos gamma equals to the component of z over the same magnitude. So that means 4 divided by the square root of 29. What angle is it giving? Yeah? Yeah, 42 point what? 0 degrees. You've gotten your free 6 marks. Just do that. If you can tell this question, it means you need to see. I don't know if you understand English or not. Now, let me make you master. Every time you are given a single vector and they ask you to find the angle of that vector, always think of cosine. Always think of cos. When you are given a single vector and they ask you to find the cosine direction, it means find alpha, beta, and gamma. Because beta is x over r, cos gamma is z over cos beta is alpha, right? Cos alpha is z over r. Yeah. Now, I want you to focus on these angles. Now, let us use the same angles to prove that it is equal to 1. I want you to focus on those angles and let us prove that they are equal to 1 using cos alpha, cos beta, and cos gamma, like the previous proof we did. Understand? Now, the question will be, they will give you these angles, and then they ask you to say, prove that cos alpha square plus cos beta square plus cos gamma square equals to 1. And they will give you these angles using the same angles. How would you do that? That's the question. So now, my question will be using alpha equals to 68.2, using alpha equals to 68.2, beta equals to 123.9, and gamma equals to 42 degrees. Show that, and it will just carry 2 marks. Show that cos square alpha plus cos square beta plus cos square gamma equals to 1. So using these angles, show that cos square alpha plus cos square beta plus cos square gamma equals to 1. How do you do that? Your job is just to substitute and use it, right? That means, what is the other way of writing cos square alpha? You say cos alpha square plus cos alpha cos beta square plus cos gamma square equals to 1. Now, are you given alpha? What is alpha? So that means cos what? 68.2 square plus, are you given beta? What is beta? 123. Where there is beta, we just put the angle that's given. So cos 123.9 square plus, what is gamma? Gamma is what? Gamma. Yeah. So you say cos gamma, which is cos square, equals to what? Equals to 1. You are proving that whatever you do this side gives you 1. Whatever you do this side gives you 1. Now use your calculator and add the answer. What is cos 68.2 square? Give me the answer. What is cos 68.2 square? Use your calculator. What is cos 68.2 square? 0. What? 0. What? Yeah? 138. 138. Plus, what is cos 123.9 square? What is cos 123.9 square? It's giving what? 0.0. So 0.31. Okay. 0.31. Plus, what is cos 42 square? 0.5. 3 equals to 1. 2, 3. 2, 3 equals to 1. Now, just add these numbers. If they give you 1, it means it's proved. Just add 0.138 plus 0.311 plus 0.5523 and see it's going to give you 1. After you add, this is giving. What is the answer? Yeah, 1.2. So that means 1 equals to 1, right? Yeah, so hence proved using the angles. Yeah. Yeah? Where? I can't see him. I can't get you. What are you? Yeah. Where? Or how can you even find 0.9? From where? In case 4. If you find that error was that calculator 2 is not equal to that, it means it's not true. So guys, are you seeing that? If it's 0.99, it can't even be 0.99. Where? Why? Because all angles that you use, if you add the angles, the answer will be 1. So it can't. It can't. It can't give you that. If it gives you, you say it is not. I can't even give you 1. Are you allowed to go? Yeah, please. If you want, if the calculator is not true, right from the figure. So guys, using the angles alpha, beta, and gamma, we've shown that this one equals to 1. Using the angles, right? It's simple. Very simple. So, we are still here. We have done vectors in 3 dimensions. You need to memorize that plane name. How to move from x to y to z and go back to x. Now from there, you need to remember cos beta, cos alpha, and cos gamma. How do you find alpha, how do you find beta, and how do you find gamma? That question carries about 6 marks. You need to remember that. Now, the next thing we'll look at tomorrow in the morning, dot and cross product using ij and k. Or now, guys, it's 18 point something. Now, we learn from 17 to 18. So evening is just 1 hour.